Make sure that you do know how to classify triangles. You know the difference between acute, equiangular, obtuse, and right. And not only that, you can classify them by sides. There's your 3 side classifications. Equilateral, all 3 sides are equal. Isosceles, 2 sides equal. Scalene, none. Some other things about equilateral and equiangular. Anytime you have an equilateral triangle, it will also be equiangular. And if that's the case, what's 3 angles going to equal? All 3 angles will be 60. So if it's equilateral, then it's also equiangular, and all 3 angles will be 60. If you have isosceles, anytime you have 2 equal sides, you will have 2 equal angles. This thing is not setting on its base. If it were, okay, this would be the base. Know the parts of your isosceles triangle. This is your base. These 2 things are called your legs. The legs are always the 2 equal parts. Then you have different types of angles. This is called your vertex angle. The angle between the 2 equal sides is your vertex angle, and since this is your base, these 2 angles are your base angles. And then scalene, the only other thing to know about scalene, all 3 angles will always add up to 180, and we'll touch on that here in a second. Okay, triangle angle sum theorem. Again, make sure that you know all 3 angles will always add up to 180. You don't need to know anything about the proof. Again, don't forget, you got this hourglass looking thing here. Don't forget about your old material. That if you're dealing with 2 lines crossing, you'll have what's called vertical angles. These 2 angles will always be the same. There will be more than likely some problem mixed in on the test where you have 2 different triangles that are across from each other like this, to where you'll have to know that these 2 angles in that triangle will be the same because they're vertical. Also, more old material that will be mixed in. Anytime you have a straight line, such as here, you'll have what's called a linear pair. Linear pairs are always supplementary, meaning that these 2 angles will always add up to 180. If you have a straight line, you'll always have a total of 180. Something else that I noticed about this that people are going to get confused by, there's 3 triangles here, not 2. Okay, make sure that you're able to spot all the triangles. There's a small triangle, and then there's the big triangle. So if I were to give you this angle measure and to ask you for this one, you could actually use angle sum theorem and see that this is 99 degrees. We know this. You could find that by using the 3 add up to 180. Extended ratio problems, we did these back in chapter 1. Anytime you have an extended ratio like 1 to 2 to 3, make sure that you know that those aren't the angles. Those are that's the ratio of the angles. So if 1, 2, and 3 is the ratio, that means the actual angles be 1x, 2x, and 3x. Some multiple of 1, 2, and 3. And since those are angles, we know that when we add them, we'll always get 180 degrees. Solve that for x, plug it back in. I think you get actually x equals 30 there. And once you plug that back in, you have 30, 2 times 30, and 3 times 30, which would be 30, 60, and 90. Exterior angle theorem. You have 3 interior angles, and you also have 3 exterior angles. An exterior angle is simply an angle that's on the outside of a triangle. Notice that exterior angles are always supplementary with the corresponding here interior angle. You have the exterior angle theorem, which states to find, and this, honestly, the exterior angle theorem is simply a shortcut. To find the measure of an exterior angle, you add the 2 remote interior angles. I think that might be actually a true-false question. To find the measure of an exterior angle, you'll add the 2 remote interior angles. And the reason for that is angle 1 and this angle here next to it is supplementary. This angle and the sum of these 2 angles are also supplementary. So if 2 things are supplements of the same thing, then they must be equal. So angle 1 is equal to angle A plus B, which is what you see there. And here's the type of problem that you might see. To find the measure of angle 1, the easy way, this is remote interior, this is remote interior. This is not remote interior. To find the measure of angle 1, you can just simply add those together and give you 79. So angle 1 is 79 degrees. Corollaries, you really don't have to know these because, again, corollary is pretty much the same thing as the theorem, just a little bit different. This corollary states if you have, well, since the 3 angles add up to 180, if you have a right triangle, well, that takes care of 90 of it. So the 2 acute angles will always add up to 90. They're not 45 and 45 every time, but they do add up to 90. They might be 30 and 60, 20 and 70, and so on and so forth. And the second one you probably know for previous classes. It says that you can't have more than one right angle and you can't have more than one obtuse angle. Because if you have more than one right angle, that's already 180. Okay, you can't have a third angle. And the same thing with two obtuse, that's already more than 180. And they all three have to add up to 180, so that's not possible. This is big on the test. Just make sure you know that if you do have an isosceles triangle, if the two legs are the same, then the two base angles are the same. Don't get it mixed up. Don't think that, well, I don't know if these two are the same. I don't know if these two are the same. Set it on its base. If this is your equal sides, this is your base. Set it on its base. It'll be the two base angles, the two bottom angles. And the converse of that, and a reminder that converse just flips your if and then in your statement. The converse of that is also true. If the two angles are the same, then the two sides are the same. Reminder, and again, I'm pretty sure this one is on your test. If the two sides are the same, then the two base angles are. And a lot of people are going to look at this and say, yeah, there's the two sides are the same, and there's the two angles that are the same. No, it doesn't fit. Okay? If these are the two sides, this is my base. If this angle, if this angle is 2x, then that means this angle is also 2x. That's your base angles. So it looks like this is an isosceles triangle, but it's actually an equilateral triangle. Because 2x, 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 they're all three angles are the same. And each of those angles would have to be 60. Because in an equilateral triangle, all three angles are 60. Because it's also equiangular. So that means that 2x is 60, so x must be 30. To find the side length, and I can't remember if both of them are on the test, but I know that one or the other. You're going to have to either find sides or angles here. To find the side lengths, well, since it's equiangular, it's also equilateral. So that means that 4y minus 5 would have to be the same as 3. Solve that by doing 4y minus 5 is 3, and you should get y is 2. Here's another, that type of problem. Again, isosceles triangle, which means these two are the same. And here's how I would work this. We know that this is also 6x plus 8. That's probably not how I would work it, though. Let's go through a thought process here. If this is 80 degrees, your vertex angle is 80. Does everybody understand that the other two angles would have to add up to 100? Because all three are 180, so if this is 80, these two add up to 100. Well, since these are the same, that means these are the same. So that means that this would have to be 50 and 50 because they add up to 100. They're the same and they add up to 100. That's the only scenario. So each of these is 50. So why not just say 6x plus 8 is 50? The other way of saying it, you could say 6x plus 8 plus 6x plus 8 is 100 because those two are the same. Or you could say 6x plus 8 plus 6x plus 8 plus 80 is 180 because all three add up to 180. But this is probably going to be the easiest way. And you would get x is 7 if you solve that. Since it's isosceles, if I ask you to solve for sides here, you would simply set 4y minus 2 equal to 2y plus 2. And I think you get y equals 2 there. And that would make this 6, and that would make this 6. Always plug it back in to check and see if you did it correct. Another theorem. The bisector of the vertex angle, if you have an isosceles triangle, in isosceles you have two equal sides. If you have an isosceles triangle and you split the vertex angle, meaning this angle is the same as this angle. Well, we already knew that this angle was the same as this one. And if these two angles are the same as these two angles, we haven't done it yet, but there's what's called a third angle theorem. Those would have to be the same. And if those are the same, it have to be 90 and 90. You got all this symmetry happening here. Anytime you draw an angle bisector, anytime you draw a perpendicular bisector, it splits an isosceles triangle perfectly into two equal right triangles. So that's pretty much what this theorem states. The bisector of this vertex angle is the perpendicular bisector of the base. So if you're going to bisect this angle, this theorem says you also will bisect the base, and it'll also be perpendicular to the base. It forms two congruent triangles, two congruent right triangles. So here you see an example. This is going to be a line of symmetry because it splits that, it splits these angles. These are right angles. So you've got two perfectly congruent triangles. So if angle L is 58, that means this angle is 58. So you have 58, 90, and you could find these smaller angles as well, which is, I think, what you're looking for there. On tomorrow's test, I have noticed this. Most of your true-false problems involves points of concurrency. Let's review all your points of concurrency and make sure that you remember each one. There's 3 points of concurrency that will be on your test. You'll need to know what a circumcenter is. Circumcenter. You'll need to know what an incenter is. And you'll need to know what a centroid is. And spend a good bit of study time on this. A circumcenter is the point of concurrency where the 3 perpendicular bisectors cross. An incenter is the point of concurrency where the 3 angle bisectors cross. And the centroid is where the 3 medians cross. So first thing you need to know about circumcenter, incenter, and centroid is what is the point of concurrency for? Circumcenter, perpendicular bisectors, incenter, angle bisectors, centroid, medians. And then you need to know what's true about them. The circumcenter is, well, it's the center of the circle that you can draw around a triangle. So let's say that this is the circumcenter. And if that's the middle of the, if that's the middle of the circle that can be drawn around this, then that means that I could draw these 3 lines, and they'd have to be the same. Why? Because that would be the radius. Those three lines right here would be the radius of the circle that can be drawn about it, and since those are the same, we can say that a circumcenter is equidistant from the vertices. That's what's special about a circumcenter. It's where the perpendicular bisectors cross, and the circumcenter is equidistant from the 3 vertices of that triangle. And incenter, okay, the incenter, if you have a triangle and you find the incenter. Let's say that let's say this is your incenter. What's special about an incenter? It's the center of the circle that can be drawn inside the triangle, which means that the radius of that circle would be this. So if you could draw a circle inside it by using the incenter, that means that these 3 distances would be the radius of that circle. So the incenter is equidistant from the sides. And then you have the centroid, which is where the 3 medians cross. And if you don't remember a median, find the middle, which is about right there, and draw a line from the angle to the middle. Find the middle here, draw a line from the angle to the middle. Find the middle here, draw a line from the angle to the middle. That would be the centroid. The centroid is the point of balance. Okay, it's a triangle center of balance. Centroid, center of balance. So what's special about the centroid? What else is special? If you take these segments here, take this red segment and the rest of the segment, it'll always be a 2-to-1 ratio. That's the centroid. I did give you a shortcut for finding centroid, just in case I give you one to where you have 3 points, and I ask you to find your centroid. Centroids and midpoints are pretty much the same thing. To find a midpoint, you add your x's and y's and divide by 2. To find the centroid, you add all 3 of your x's and add all 3 of your y's and divide by 3. So on tomorrow's test, 2 things you'll have to do. I'm not going to ask you to find an incenter, and I understand why I didn't do that. In order to find an incenter, you'd have to do the angle bisectors, and it's hard to do without a protractor. But I'm going to make you find a circumcenter given 3 points. I'll make you find a circumcenter, and I'm going to make you find a, what's the other one I said, centroid. So if I ask you to do that, here's how you do it. -5, 6. Let me plot these. Okay, there's the 3 points. There's the triangle graph. If I ask you to find a circumcenter, from what we just wrote, a circumcenter is the point where the 3 perpendicular bisectors cross. So what you're going to have to do first is we're going to have to bisect all 3 sides. We're going to have to bisect it with a perpendicular line. So to bisect it, take this point, find the midpoint, add your x's, divide by 2, add your y's, divide by 2. Take these 2 points and do the exact same thing. Take these 2 points and do the exact same thing. And I've done that so many times I just knew where they were. Okay, there's your 3 points of that's your 3 midpoints. To draw lines perpendicular to it, it's easy here. Okay, since this is a vertical line, you'll draw a horizontal line. There's the perpendicular bisector. It crosses through the midpoint and it's perpendicular. Same thing here, pretty easy. And I was off on this midpoint. I was bragging too much. This midpoint should have been, actually this whole line is just way off. Let me erase it and redraw it. So here we go. The actual midpoint of that last one I just drew, if you take, this is -5, -4, and this is 7, 6. Add the x's, you get 2 divided by 2 is 1. Add the y's, you get 2 divided by 2 is 1. 1 is the midpoint right there. Let me do it in blue since I did the other ones in blue. Now, if you ever had to draw a perpendicular bisector of a slanted line, okay, horizontal vertical lines are easy. But if on tomorrow's test you have to draw a perpendicular bisector of a slanted line, find the middle and find the slope. The slope of this line is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. This is 5, 6. There's a slant of this line. If you need to draw a perpendicular line to that, the slope of it would be, instead of 5 over 6, it would be -6 over 5. The opposite reciprocal. So from this point, go down 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5. That's going to be the perpendicular line through that. Let me get my line tool here. Actually draw it. So there's your 3 perpendicular lines. I actually drew them in different colors. I hate that I did that. This is a perpendicular bisector, this is a perpendicular bisector, and this is a perpendicular bisector. They all 3 cross at 1, 1. On the test tomorrow, you don't have to find out where they all 3 cross. If you feel confident about it, do 2 of them. Where 2 of them cross, and on this one especially, that'd be pretty easy to draw where those 2 cross. We'll find out where 2 of them cross. The point where 2 of the 3 cross, or all 3 of the 3, would be the what we're looking for. Let's clear it and do the next one. There's your triangle again. The centroid, honestly, centroid is hands down the easiest one to find. Okay, if I ask you to find the centroid of this, and we do have a shortcut now, but to find the centroid, again, find the midpoints. Same thing we just did on that last one. Find all 3 of your midpoints, and the centroid, you're not going to look for the perpendicular bisector. You're looking for the medians. A median, here's the only difference. A median does not go, it's not perpendicular to this line segment. A median goes from the middle to the angle. So you'll just draw your lines this time to the angle instead. This one does not have a nice, neat whole number median. The one I give you on the test tomorrow will not be like this. It'll be like 2, 3 is the answer. It'll be a nice, neat whole number. But it looks like it's going to be like -1 and maybe 2.7. -1, comma, something like 2.7 on that. The one on your test tomorrow, again, is going to be whole numbers. Reminder, the shortcut for that, just add all your x's divided by 3, add all your y's divided by 3. So let's see how close I was on my answer. -5, 7 is 2. 2 and -5 is -3 divided by 3. Dead on. I'm good there. Add your y's, you get 12 minus 4 is 8 divided by 3, which is 2.6 repeating. So we were right. -1, 2.7. Also with the centroid, make sure you remember this. I've already thrown this out there. I just want to remind you. It only centroid. This only works for centroid. When you're dealing with a centroid, there's a 2-to-1 ratio of the line segments. Meaning, if this is 4, it'll always be double the little piece. If the little piece is 1, it'll always be half of the big piece. If this big piece is 6, the little piece will be 3. So make sure you know, when you're dealing with a centroid, when you're dealing with that point of balance, there's always a 2-to-1 ratio of the line segments. Next thing on your test, triangle inequality theorem. If I give you 3 side lengths, such as 2, 7, and 10, and I say, can you find a triangle? Can you create a triangle with these 3 side lengths? You would tell me no. The triangle inequality theorem states that the 2 smaller sides has to add up to be bigger than the bigger side. Here's the reason why. If this is 10 and you try to create a triangle with side lengths 2 and 7 on the side, they're going to hit before they touch. They're going to hit the actual bottom. So these two have to add up to be bigger than the other side. And I'll go ahead while we're on this subject. If they do, let's take the numbers 3, 4, and 6. And I say, is this a triangle? You'll tell me yes. And then the next step might be, well, since it is a triangle, what kind of triangle is it? Here's how you do that. A squared plus B squared and C squared. If A squared plus B squared equals C squared, it's what kind? Right. If it's not, then it's either acute or obtuse. It has to be one or the other. Okay, right, acute, or obtuse. So you test this. C is always your biggest side. A and B are always the two smaller sides. So this is 9 plus 16. And this is 36. So you have 25 and 36. The rule is look and see which side's biggest. If they're equal, it's a right triangle. But if you make, in this case, C is bigger. Here's C. C is always the hypotenuse. If you stretch C and make it bigger, what happens to this angle? It is now obtuse. So therefore, if C is bigger than A squared plus B squared, you'll always have an obtuse triangle. If C is smaller, you'll always have an acute triangle. Concerning the triangle inequality theorem, you do have one on your test tomorrow like this. What if I gave you two sides and I said, okay, what's the range on that third side? Well, you've got two scenarios there. 8 might be the longest side. And if 8 is the longest side, then you have side lengths of 4 and x as the shorter sides. In order for this to be a triangle, x can't be 4. If x were 4, it's going to shut. So therefore, x has to be bigger than 4 in order for it to hit before it closes. Your other scenario is what if 8 and 4 is actually the shorter sides and you don't have the longer side. If that be the case, x can't be 12. If x were 12, it would shut, okay, before it hits. So we're going to have to, in order, if this were 12, it's going to shut all the way. So in order to make these hit before they shut, we're going to have to shrink that down a little bit. X will have to be smaller than 12. So if x has to be bigger than 4, x has to be smaller than 12, that means it has to be between. Let's redo that. Reminder about interval notation. If I do these brackets here, that means it includes 4. X cannot be 4. This cannot equal 4. It will not be a triangle. So let's go and write it like this. It has to be between 4 and 12. It has to be bigger than 4, smaller than 12, so that means it's between 4 and 12. There is a shortcut for that. 5 and 11, you can subtract them, you can add them. That'll have to be between 6 and 16. That's the easy way of working it. Angle side relationships, just make sure that you know the smallest angle will be across from the smallest side, and the largest angle will be across from the largest side, and the only one that leaves out is the medium. The medium angle will be across from the medium side. So if I give you a problem such as this, to where you have to put them in order, the smallest here would be, well, this is the smallest side, so here's the smallest angle. This is the middle side, so this is the middle angle. This is the largest side, so this is the largest angle. So QRP would be the angles in order from smallest to largest.